Welcome, dear listeners and viewers, to this episode of Geopolitiek Nu, where we will discuss the geopolitics of the Arctic and climate change. As you might have noticed, it will be in English today. The reason for this is our very honored guest, Mark Drinkwater. He is the head of the Earth and Mission Science Division of the European Space Agency, ESA. Thank you very much for coming. Before I will give you a chance to introduce yourself, I would like to ask our viewers and listeners to subscribe to our channel. Leave a review if you like this content, for example on iTunes and Spotify. This helps us enormously to grow and let more people say goodbye to their uninformed self. Of course, I'm here also with my good friend and colleague Rajeev Lachmipersad. Mark, we've met each other for the first time in our trip to Spitsbergen or Svalbard in 2018. For those who don't know this place, it's the closest inhabited island to the North Pole. I'm very happy to meet you today again. It makes us very proud and grateful. Could you please introduce yourself to our listeners and viewers?
Thanks very much for having me. My name's Mark Drinkwater, as mentioned. I work at the European Space Agency. We're based in Noordwijk in the Netherlands, where I head the Earth and Mission Science Division. The Science Division is part of our Earth Observations Programs Directorate, in which I'm responsible for a group of scientists and scientific activities to support the design, the development and the operation of some of the European Space Agency's Earth observation satellite missions. We produce a wide variety of information products from our satellites, and we'll get into that a little bit later. But my division is comprised of scientists. We support a variety of studies and activities to consolidate new ideas for satellite missions. We go from proposal on paper to conceptual design of the satellites. And we do this in close cooperation with the engineers at the European Space Agency and throughout Europe. We work closely with scientists and users of satellite data and information products to ensure that the satellites are being designed to fulfill the needs. Those are needs of the science community or operational users, such as numerical weather forecasting community, for example. And we can talk a little bit more in depth about that later. But we, at European-wide level, the European Space Agency is comprised of 26 member states. We're a so-called intragovernmental organization. We're not a national space agency. ESA was founded around a convention to support space activities within those 26 member states. And so we are providing a broad variety of support in the space domain to each one of our member states. I'm a geophysicist by background. I studied the use of radar over ice in the Arctic in the early 1980s. Before there were any systematic radar measurements being made in civil space, at least, from satellites. And after graduating from the university at the Polar Research Institute at the University of Cambridge, I went to work at Caltech, NASA Jet Propulsion Laboratory in California, in Pasadena, where I became a research scientist specializing in the use of space-based techniques in studying the polar regions. And I've developed a career over the last 35 years where we've been looking at the use of satellite technologies in monitoring what's going on in the Arctic, what you could call in another domain as space-based situational awareness or environmental awareness. You could use different terminology depending on which community you come from. But fundamentally, I'm a scientist, and so we're engaged in the use of those information in Earth system science to better understand what's going on, particularly in the high latitude regions.
So what are you studying there? To what are you paying attention in the Arctic?
We're paying attention to the processes at work that are underlying environmental change. Of course, we'll get into the details of the impact of global warming and climate change, particularly at high latitudes, because we understand that the rate of change in the polar regions is much more dramatic than elsewhere on Earth, and that's driving changes in different elements of the Earth system. It's driving changes in the ocean and the ocean dynamics. It's driving changes in the atmosphere and the atmospheric composition and the circulation of the atmosphere. It's changing the energy balance. It's changing the ice cover. It's changing terrestrial ecosystems with the greening of the Arctic and the precession of ecosystems as warming's taking place. And of course, the impact of all of these changes is opening up the Arctic, and it's leading to dramatic changes in terms of accessibility and the way in which the surrounding states view the Arctic as not only a source of resources, but also for transportation across the Arctic.
I also think that the difference is that if you look at climate change, normally people see changes. If you are living in the deltas in Bangladesh or also in Netherlands, also a delta country, or if you're a farmer, we also have severe droughts, and our farmers also have problems with that. But if you're talking about the pole of the poles, the North Pole, or the South Pole for that matter, I think not many people live there or around there, so they don't see the danger as much as anywhere else, I think.
I think it's misunderstood largely and thought of as a rather benign, inaccessible, frozen area, which doesn't have a very big impact on the majority of the people. But the rate of change and the impact on the rest of the world is measurable. In fact, there's been a saying over the last few years that whatever changes take place in the Arctic don't only impact the Arctic, they have an impact elsewhere around the globe. And so the reverberations of changes that are ongoing on the Arctic today certainly have consequences for the rest of the world. And we can get into that. They can impact ocean currents, which transport heat and energy around the rest of the globe. And the atmosphere of the Arctic is connected to the atmosphere of the rest of the globe. And so what you pump into the atmosphere in terms of, say, carbon dioxide or whatever has an impact on the greenhouse effect for the rest of the world. So
the influence of the Arctic is huge worldwide in different disciplines and also different aspects of life, ecological, geopolitical, economical. We will address a few of those in the minutes or hour to come. I would like to bring you back. You have a long career now in science, 35 years. In satellite, you're the head of a scientific teams, developing different scientific activities. Can you identify for the listener, why is the European Space Agency on Earth, or actually in the universe maybe?
Well, space, since the Cold War, of course, access to space has been a driving force for space-based activities, be it in Russia, be it in Europe, or be it in North America, and now elsewhere around the globe. You can see space powers developing around the globe. Access to space is something which has driven aeronautics and space technology. And the European Space Agency was founded largely to capitalize on this endeavor. Of course, we've not been around, say, as long as agencies like NASA, but we've gained a very strong foothold in the space business particularly over the last 25 years, where we've developed a capacity on behalf of Europe, which is producing fantastic data, be it for scientific use or for operational uses. And I can go into a little bit more detail about some of those aspects of what we're doing, particularly in the Earth observation business. I think our place in space is bigger than just Earth observation. ESA, as you're aware, sends probes throughout the universe. We've landed on asteroids. The Rosetta mission has a place in many people's minds and memories after ESA, not NASA, managed to land a space probe on an object that was moving through the universe. And Rosetta really captured the imagination of many people around the world. Most recently, we launched a satellite that's gone to Jupiter, the JUICE spacecraft. And so we have science encompassing planetary science or astronomy or aspects of studying the universe, which are much broader than simply focus on Earth. However, my background is focused solely on Earth, and in particular how we can use
I think
Earth
the
observation
most
data.
interesting about space science is I think space is something that has interested mankind from the beginning of mankind. If you look at the first temples, the first construction, like Göbekli Tepe in the present-day Turkey, it's all about what they are seeing in space. They are picturing that in all the religions you see that back. So I think there's something that's inherent in us, in our DNA, you can say. If you look up, unfortunately, if you're now looking up, we don't see as many stars, but I have seen picture that if it's dark, like it used to be, you can see the entire space. But I think the most important part of space technology, if you look at it, NASA, but I think also ESA, if you are doing research on space and innovating on new technologies, but I have seen many documentaries that because of those innovations, many civic innovations come out of that we are using in our present day lives, like GPS. We can't live without GPS. That is from space. I have seen many innovations in the medical world. MRI scan are from this. Also from agriculture, because we want to plant on Mars. We want to agriculture on Mars eventually. I think that's the most important part of space technology is, of course, knowledge about space is important, but the many side effects or the positive side effects we can't even believe now from what is coming out of space technology.
Yeah, I think there's two important themes out of what you said. One's about how space has magnified our understanding of fragility of life on Earth, first of all, because the astronauts get this perspective known as the overview effect for how fragile life on Earth. And that's led to questions about our existence in the universe and whether we're a unique life form in the universe, of course.
And whether we are alone.
And whether we're alone. And then on the other side, space has led to all of these spin-off technologies that you speak about, and of which there are many. Space factors in everything we do in our everyday life today, from weather forecasts that you get on your mobile phone and that dictate whether you're going to go on your bicycle to work or not, to the forecast of the temperature and whether it's going to rain. At the same time, you know exactly where you are from 1 minute to the next because of these global navigation satellite systems like GPS.
Agriculture, everything.
Yeah, we drive tractors in the fields today in so-called precision farming. The tractors can increase the efficiency and productivity in the agricultural sector. And on the other side, we've got all of the key technologies that find their ways into your phone, in your car, in everyday life. So space has had countless.
The civic uses and applications of space technology are huge. I have a question about ESA. Is it meant to only address these civic and scientific goals, or also geopolitical and maybe military goals?
This is a very interesting question because our convention does specify quite clearly that it's space for peaceful purposes. Of course, space spans many domains of interest nowadays because information about territories can be perceived as being of security interest and therefore also be of use in a military domain. But what we do is first and foremost for peaceful purposes. European Space Agency runs from public money. So it comes from taxpayer money in each of the respective member states. But the most important principle...
Who are the member states? I think the European Union, most of the states, also other European countries?
We're not a European Union space agency. There are other European countries like Switzerland or Norway who participate in ESA, which are not in the EU. We have the UK as well, which is no longer in the EU. And so it's not an EU organization. Our convention existed since before the EU. But of course, many of the countries are common to the European Economic Zone. So from that standpoint, the principle is that we help member states to develop their aerospace and technology competence. And by smaller member states working with the bigger member states like Germany, Italy, France, UK, and by working in collaborative environment within our projects, we can bootstrap industry and help increase the technical competence of the smaller member states. And so there's a collective basis for wanting to work together. And that, of course, has spin-offs for the entire economy throughout Europe.
Okay, so the main purpose is peaceful and for civic and also scientific purposes, but there can be military spin-offs that are not directly caused by ESA. Do I have to view it like that?
Indeed, because many of the technologies are both common to the security sector and common to civil space endeavor nowadays. And of course, we develop technology for some specific purposes in the civil space sector, which could also be applicable across the boundary into the security sector. So yes, we could call that dual use to a certain degree. And many of the satellites which are funded by public money today also have benefits on the other side of the equation, of course.
Okay, and is the pressure now a bit bigger since last year to use ESA for military uses?
There's a debate which is raging at the moment about the use of space-based security. Of course, the space perspective from the standpoint of viewing country scale or regional scale is ideal for monitoring what's going on in a particular region in the world. That's the benefit of going to space. We have this big picture, whilst we can also zoom in to look at details of the landscape or what's going on there. So that has obvious applications in different areas. It can be used for surveillance. It can be used for understanding how to make your farming sector more profitable, or it could be used for spotting what's going on in military zone or a demilitarized zone. But the focus for what we do is revolving around applications for peaceful purposes, and the data are clearly applicable in the other.
It's like the spin-offs are in every sector, so also in military,
Absolutely.
in transportation, agriculture.
Absolutely.
Yes.
Okay, I think this is a nice moment to bring us to the Arctic. That's one of the most important study subjects you're studying right now or over the last few decades. What is the Arctic and what does it make so special, according to you?
Well, excuse me.
Mm-hmm.
You could define the Arctic in a number of different ways, really, depending on how you view the Arctic, whether you're an Arctic state or whether you're outside the Arctic in some way. One simple definition for the Arctic, it would be the circumpolar north region of the Earth, which includes the edges of the Eurasian continent and the North American continent. This, of course, encompasses the adjacent waters of the Arctic, the Pacific and the Atlantic. But I think it's probably more common to think about the Arctic in terms of its existence in the past as a glacial part of Earth's environment. And so the common definition for the Arctic region would be the place on Earth at high latitudes where the average temperature for the warmest month of the year is below 10 degrees Celsius or centigrade. And that's an area which encompasses approximately 25 million square kilometers. So it's an extremely large area on Earth, which has a variety of environments which encompass both the terrestrial domain and the ocean domain. Of course, ecologists also prefer to associate the Arctic boundary with the frontier in terms of the tree line. Mm-hmm. This makes the region even bigger than the definition, which would go by temperature or the 10-degree isotherm.
Tundra taiga.
Yes, the tundra taiga boundary, for instance, where the tree line is advancing further north as the Arctic warms, for instance. So you could consider an even bigger region if you use that definition of the boundary of the tundra taiga. And then probably what makes the Arctic so special is that geographically it's dominated by the Arctic Ocean, which is connected to the Pacific Ocean through the Bering Strait. And it's also connected with Baffin Bay through the Canadian archipelago and through the Nares Strait, which is a narrow passage of water between Greenland and Ellesmere Island. Mm. And then we also have the connection to the North Atlantic through the Greenland Sea and the Barents Seas. And so it's a largely enclosed basin, which is connected through a few narrow areas where the Arctic Ocean interacts with the rest of the global ocean. And so it's quite a unique place. So the region, of course, has had this impression of being largely a frozen area. Of course, for much of the year, the Arctic Ocean is covered by sea ice. And at the same time, the terrestrial ecosystems maintain in a rather frozen state for the majority of the year. And so it's remained isolated and largely inaccessible. But of course, with climate change now, the Arctic's opening up as the sea ice is receding and as the place is thawing.
Yeah, that brings us to the next subject. How is it physically changing? And is it really opening up? And what will be the consequences of the Arctic opening up?
Well, the changes in the Arctic over the last decades have been quite dramatic. And in terms of air temperature, first of all, most of the Arctic regions are warming at a rate which is 3 times or more than the global average.
What is the global average?
It's 1.3 degrees, I guess, above the industrial temperature at the moment. And with the very different climate predictions that we've seen by the IPCC, depending on the amount of CO2 emissions, we can foresee rises in the temperature over the next few decades up to a level of 1.5 degrees or perhaps even more,
yes,
depending on the emissions scenario. But the consequence, of course, of the global warming is that the Arctic has this tendency through what's known as Arctic amplification to warm faster than the rest of the world. And we can get to the processes responsible for that in just a moment. But that means that as a consequence of this Arctic amplification, most Arctic regions are warming 3 times faster than the rest of the globe, with some regions such as the Barents Sea warming at 5 to 7 times the global average.
Oh, wow.
Those are verified by weather stations in Spitsbergen, Svalbard, or Franz Josef Land. And so there are regions in the Arctic which are warming even faster than the typical average. Now, there are a number of reasons why that's the case, and let's study the reasoning in connection with ice and snow, first of all. Of course, as the Arctic warms, the amount of ice and snow cover is reducing. If you think about the sea ice, which is the majority of which is seasonal ice cover, it grows in winter and it shrinks again as it melts in summer months. That ice is covered by snow, which falls on the surface of the sea ice, which grows in the ocean as the winter season progresses. But as the onset of summer comes, the snow surface begins to melt. And as snow begins to melt, the albedo, or the reflectivity of the sunlight, goes down. And so more and more energy is absorbed from the sun. This accelerates the melting. It reduces the area of ice. And as you expose more and more of the ocean surface, more and more energy from the sun is being absorbed because the ocean is relatively darker than the rather reflective snow and ice surface. So the less ice we have in the Arctic, the greater the temperature increase. And so this has a positive feedback, with reduction in ice resulting in less and less energy being reflected outwards into space. So the Arctic self-regulating capacity is being reduced by reducing the area of snow and ice in the Arctic.
So there are accelerating effects of the warming of the Arctic.
Exactly.
And this will have consequences worldwide for many ecological systems, ocean system, energy distribution. If we really take a look at the Arctic, what does it mean, geopolitically speaking, for the Arctic and the access to the oceans, for example, from Russian perspective?
Well, not only from Russian perspective, but of course, the reduction of the sea ice in the summer months is having the biggest impact on the accessibility of the Arctic. Of course, there have been 2 primary seaways that one could use through the Arctic. The northeastern sea route, which passes from northern Norway throughout the Russian sector of the Arctic to the Bering Strait, goes through Russian waters. And the decrease in the amount of sea ice during the summer months there has led to a massive increase in the amount of shipping, because it facilitates a far more efficient sea route between Asia and Europe in particular. And the volume of shipping, of course, is anticipated to increase as we reduce the sea ice. But there are many other things that happen as a consequence of opening up the sea ice in the summer months, not least the amount of fishing that can go on, exploration for raw materials, oil, heavy metals, and many other things which you could do up there prospecting-wise.
So, do you think this opening up will increase over time, the opening up of the Arctic? Do you think we have an almost free access in 2050 or 2060 throughout the year, or is it going to be more access only during the summer?
Well, that's why we're studying. That's why we're studying it. Of course, accumulating information about the Arctic is enabling us to better understand the processes. And in doing so, we can develop better models for the purpose of predicting how things might evolve in the future. Of course, there are many non-linearities in the Arctic system that make it quite difficult to predict exactly when the ice might be completely gone in the summer months. But there are other consequences for infrastructure if you want to build roads on land. Degradation in permafrost, for instance, and prevents very simple engineering solutions. And so there are many complexities that come with thawing of ice in the Arctic, be it on land or beneath the surface of the land surface, or be it the sea ice on the ocean, or be it the ice sheets and ice caps on land. Of course, recession of the ice caps in the Arctic is another factor which opens up areas to exploration. And so that's been a driving force for much of the economic interest in the Arctic, of course.
Looking forward is really difficult. You've told before, indeed, that there's non-linearity. So you don't know that when a variable X is increasing, that variable I will increase with the same amount too. That's very hard to predict. If you look back over the last 3 decades, Has the Arctic changed more than you expected upfront or less? And does it indicate how we have to view the future?
Yeah, that's an interesting question because, of course, I've set eyes on the Arctic on many occasions since I started doing polar research. And I think the changes are dramatic and easy to see and follow with the eye, although we have this satellite perspective, which helps us as well, in addition to having had the expeditionary experience to see what's actually going on the ground. Yes, the changes are dramatic and worrying, but our knowledge and understanding is the basis for making accurate forecasts, I believe. And if we look at how dramatically the atmospheric circulation is changing, or how dramatic the ocean...
What does that mean for our listeners? Also for me, by the way, it's quite complicated maybe.
Yeah, this phrase we come back to that I mentioned at the beginning, happens in the Arctic, doesn't stay in the Arctic. Okay, an example might be the change in temperature at higher latitude, and the distribution of temperature might influence the gradient in the temperature between the Arctic and mid-latitudes, like European latitudes. Now, what does that do? We see that it has an impact on the polar vortex, which is a circulation at high latitude, and it has an impact on the jet stream, for instance, which dominates weather patterns in Europe. Now, as you decrease the temperature gradient between the Arctic and mid-latitudes, for instance, the structure of the jet stream changes, and we see wavy structure in the jet stream. This wavy structure can build regions of high and low pressure, which have an imprint on weather patterns in mid-latitudes. And we're undergoing at the moment a blocking high pressure because of these waves in the jet stream. This blocking high pressure is forcing the weather systems along a different route. This can have consequences for the amount of rainfall in Spain. As we see, we have torrential rainfall in Spain after a period of extended drought, and the same is going on in Italy. And these extremes in the weather are being forced by patterns in the atmosphere, which are a consequence of the type of changes that we're observing. And the distribution of temperature between the Arctic and mid-latitudes is one of the underlying reasons for that. The ocean has more than a small part as well. The ocean's driving warmth into the Arctic. This is a phenomenon which could be called Atlantification of the Arctic. As warm water penetrates further and further north, we're seeing its role in removing sea ice. It's helping deliver energy and heat into the Arctic.
Atlantification, why is it?
It's because the currents which bring and deliver warm air, that deliver warm water to within proximity of Europe, that allow us to have a rather mild climate, are also delivering warm water by current systems which penetrate now all the way up into the Arctic through the Barents Sea. This is influencing the rate of warming, of course, in the Arctic, and it's contributing to the melting of the sea ice, and it's helping to change the dynamics, if you like, of the Arctic Ocean and the interaction between the ocean and the atmosphere. And so, yeah, some of these physical processes are quite complicated, and through our satellites, we're trying to understand how we can develop the information with which to put this information into computer models and forecasting capability so that we can do better predictions of how the weather or climate might evolve on short or long timescales. Yeah.
Do we also see the same degrading of what we see at the northern Arctic, also at Antarctica, for example? Is it the same picture?
It's not entirely the same picture, no. And there's an interesting paradox in that the Arctic is largely ocean, whereas the Antarctic is largely a continental ice shield. This has consequences for not only the atmospheric circulation, but also the ocean circulation, since you've got ocean revolving around Antarctica, whereas in the Arctic, you've got a largely enclosed ocean basin. So there are some quite significant geographic differences. And of course, the ice sheet in Antarctica dominates the atmospheric circulation in the southern hemisphere. So, yeah, there is a significant difference between the two. And Greenland is not slap bang in the middle of the Arctic. Mm-hmm. And so the impact that Greenland has on the circulation in the Arctic is somewhat different, say, than the ice cap of Antarctica. So, yeah, and Greenland's an interesting area for change as well. I've just been at a conference talking about Greenland because the Greenland ice sheet is changing dramatically as a consequence of warming in the northern hemisphere as well. And that's leading to increased contribution of ice melt to sea level rise, which is a matter of considerable interest, of course, in the Netherlands. The rate of sea level rise is being driven by the rate at which warming is going on in the Arctic. And as ice melts from the Greenland ice sheet, it's become, over the last 3 decades, one of the primary contributors to sea level rise.
Okay, so in conclusion, we've heard these very interesting findings over the last few decades. And although I don't like climate alarmist, but how alarmistic is the situation right now, according to you?
Well, I think the most important thing about this podcast is probably with relation to the role of the Arctic on change and rate of change in global climate and many of the impacts. I think the high latitudes are no longer a benign player in global climate. They're a very active global player in the climate system. And I think the idea that the Arctic and the Antarctic are unimportant with respect to the rest of the globe is something which has changed dramatically in terms of perception, not only scientifically, but because of the socio-economic consequences of the changes. Yeah. So I think our perception has changed dramatically, and through the body of knowledge that comes through the research that we're doing with satellite data and in the science community in general has led to much better understanding of the interconnected nature of the Arctic with the rest of the globe. And so the Arctic is going to have a dramatic impact on trade and the way in which goods are moved around the world as the Arctic opens up. And that, of course, has geopolitical and economic consequences, which will have reverberations around the world, of course. Yeah.
So the perception of importance of the Arctic has changed quite clearly. And it also causes some consequences for scientific interest. And how can you maintain, on the one hand, scientific interest, and on the other, address geopolitical, maybe economical interest? That's what we're going to discuss now. And then I would like to ask you the question, what is the interest of ESA in the Arctic? And how does ESA operate there? What are the most profound scientific interests in the Arctic? And can we still maintain those despite the looming Cold War, the new Cold War?
Yeah, that's a very important question because, of course, we work in the envelope around Earth. Our main business is in space, of course, as a space agency. But we, of course, maintain scientific connections with all of our member states who have Arctic interests. In fact, Canada is a participating state in the European Space Agency in addition to Europe. So if you like, we have tendrils of activity across many states today. Of course, we work most closely with Denmark and the Kingdom of Greenland. We work with Norway, which is one of the Arctic 5 that has a sea border. We work with the Norwegians, the Swedish, the Finnish, all of which are member states, of course. And then the other 2 states we work quite closely with, who are also members of the Arctic Council, which are the US and Iceland. Although Iceland is not a member of ESA, it is a member of the European Meteorological Organization. And so they are engaged in European business to a large extent. Now, they all have interests in pursuing research in the Arctic, and they all have important functions with respect to monitoring their coastal waters. They're all obliged to make weather forecasts to assist the logistical activities in the area. The Arctic 5 have direct responsibility for search and rescue in their maritime zone. And so that requires and desires services for search and rescue, for safety at sea, safety of maritime operations. And so those countries are also intrinsically interested in the knowledge base, which comes from measurements through expeditionary means or through in situ measurement stations, so weather stations or devices that you put in the sea or that are measuring atmospheric temperature, buoys that are floating around, for instance. But at the same time,
knowledge sharing in that field under pressure in the last few years, and
yes.
What effects will that have for the science and the scientists?
Well, we're still relatively immune because, of course, we can continue to collect data over the Arctic with our satellite. What's going on, except, of course, depending on the financial means. So that's been relatively immune. And what we can say is that the satellite sector has not suffered in the last decades Member states, of course, interests and the focus of those interests have probably changed to some degree over the last years, particularly since the conflict in Ukraine. But research-wise, the collective endeavor to study the Arctic was at its greatest over the last decades. We've seen huge experimental endeavors to access the Arctic and to collect knowledge. We've seen the International Polar Year, which many of the countries around the world entered into a collective endeavor to study the Arctic during the interval from 2007 to 2009. This spun up polar programs in many countries around the world, all of whom were contributing to experiments in the field, as well as using satellite data to monitor and study changes in the Arctic. And then more recently, we've had a huge international endeavor called MOSAIC, which was a drifting ice experiment in the Arctic, following in the footsteps of Fridtjof Nansen, which was a ship-based drift across the Arctic over a period of several months, which was resupplied by Russian icebreakers, by Chinese and Swedish icebreakers. And this also involved scientists, hundreds of scientists from around 20 different states around the world. So there's never been a bigger collective scientific endeavor in the Arctic than over the last 2 decades. And of course, we've seen a halt to that in the last year or so because of the conflict. And that's raised questions, of course, about how to interact with Russia in the future on Arctic research.
And do you have any forecast about that?
It's an interesting question because, of course, around 53% of the Arctic coastline is Russian. And so when we think about many of the processes that are going on from a circumpolar Arctic perspective, it's very important that we're able to engage with Russian scientists to have a holistic perspective about what's going on in their territory and their waters in the Arctic. If we think about some of the things that are going on, which are fundamental to understanding how climate might change, we could think about thawing permafrost, for instance. This is one of the biggest wildcards in the climate system. As the permanently frozen ground thaws, it releases large quantities of methane and CO2, both of which can contribute to the rate of warming in the Arctic and globally, of course. And so this is a wild card in the climate system at the moment. As we see Arctic warming, what we're seeing is permafrost borehole temperatures show and report the thaw. And of course, the area which is being activated as the frozen ground thaws is resulting in emissions of greater and greater quantities of
and they say
greenhouse
that
gases.
methane has a 25 stronger warming.
The short-term impact of methane could actually be much stronger, which is one of the reasons why at the recent conference of the parties they've made a collective agreement on methane emissions. Of course, with warming, we can't stop methane emissions from permafrost, and so this is an area where we're simply unable to stop the growth in greenhouse gas quantities in the atmosphere as a function of melting permafrost. So permafrost resides over a huge proportion of Russian territory, of course, and the lack of access now to Russian territory to make collective experiments on how permafrost is degrading and the impact that that's having on atmospheric loading of greenhouse gases is something that we have to recover from,
So here we can see how geopolitics is really influencing science. We cannot study permafrost as much as we were doing more than 15 months ago. And the role of permafrost and the unfreezing of it might have a huge influence on the ecological system worldwide. It causes a lot of emissions into the air of methane, and these effects are considerable, but we cannot study it right now. Do we have to feel it like that? Or less, at least, only from space?
I think it's more about the comprehensive understanding. We're beginning to use more and more the satellite technologies for understanding how much methane is in the atmosphere or how much CO2 is in the atmosphere. We've got a satellite system right now, an instrument of which has been developed here in the Netherlands. The Tropomi instrument on our Sentinel-5 precursor satellite is helping us to monitor the amount of methane in the atmosphere. So it's more this connection between what are the processes that are resulting in more and more methane ending up in the atmosphere, and the lack of ability to study those processes in situ by combining, experiments with what we're observing from the satellite. If we're going to have better forecasting models, then we need to understand the processes that are taking place on the ground, of course, as well as making the monitoring measurements from the satellites. There are other processes connected, of course, with permafrost degradation, and that are also interesting from a climate perspective, because it's not only negative things going. The greening of the Arctic, of course, is resulting in the tree line moving north, as we said before, and the so-called shrubification of the Arctic. Arctic shrubs are growing further and further north, and at the same time, these new ecosystems are altering the respiration of vegetation at northern latitudes. So we need to learn how and to what extent that's also drawing down more CO2 from the atmosphere, because that has a balancing effect. Although permafrost thaw might result in more emissions of methane and CO2, the greening of the Arctic is also responsible for drawdown of carbon dioxide, and that's having a balancing effect. And to understand in its full context both of those processes requires measurements both on the ground and in space. So you can see how important it is to be able to pursue many of these science themes collaboratively, not only with North America, Canadians and the US, but also with the Russians.
So knowledge sharing is essential to understand the Arctic and all its functions. And we have seen a Cold War before in the past. And now I'm curious, since at least in our understanding of Rajeev and myself, we're entering a new period of Cold War, at least between Russia and the West, but probably or might be also between China, Russia on the one hand, and the West on the other. What was the geopolitics of the Arctic during the Cold War?
Well, let's talk about that first of all from my own perspective in space, because, of course, geopolitics had a huge impact on the space race. It was largely because of the Cold War and the tensions that developed that were responsible for the space race, both in Russia and in the US, for instance. And that drove space agency activities after the Second War, when Wernher von Braun went to the US and helped to develop the rocket programs in the US. I was at the Jet Propulsion Laboratory, which was the place where Wernher von Braun went to help develop rockets in the US, and that led to ultimately to the Saturn V and to the moon landing. So there's an intrinsic connection, if you like, between the Cold War and rocketry in particular, because access to space was all about developing capability to launch intercontinental ballistic missiles. And that's an interesting chapter in space, which after the Cold War ended in the early 90s with the dissolution of the Soviet Union, was actually responsible for another chapter in space. We, the European Space Agency, for instance, ended up working with a European company called Eurocot. Eurocot bought many of the stockpiled missiles that had been decommissioned after the START Treaty. The Strategic Disarmament Treaty led to stockpiling, to removal of the warheads and then stockpiling of the missiles. And Rokot, together with industrial partners in Europe, bought many of these rockets and converted them into satellite launching capability. And in fact, that capacity led to launches of several of our European Space Agency satellites on intercontinental ballistic missiles. And the so-called SS-19 missile, or Rokot, as it was called, was used to launch several of our satellites, namely SMOS, Goce, Proba 2, Sentinel-3. And these were all launched from what would have been an ICBM launching facility in northern Russia, in Plesetsk, what became the Plesetsk Cosmodrome. And of course, we had, after the end of the Soviet Union, we had good collaborations with the Russians, which led to successful launches of many of our satellites into polar orbit. So we were launching satellites together with the Russians, and that was as a result of the friendly ties after the dissolution of the Soviet Union. Now, of course, the irony is we've come full circle, and we're now in this cycle where tensions over the Ukraine war have led to what might be termed another Cold War. And of course, access to space and the importance of access to space becomes magnified once again. And of course, that has an impact on driving activities in space and also budgets for defense and aerospace, probably in general. We don't profit from that as a public funded entity in Europe, But it's clear that these kind of tensions do have a direct impact on activities in the space business.
Was there also some sign of collaboration over the Arctic during the Cold War? And can we derive lessons from that collaboration that was there back then?
Well, collaboration during the Cold War, that's a difficult one. The countries that were largely involved in space in those days were developing means for surveillance over large areas. That's the origin of polar orbiting satellites as well. Of course, one of the ideas was to try to develop capability for observing the circumpolar north under all weather and cloud and daylight conditions. And civilian space has developed many radar capabilities as a consequence of war. The Second World War led to the development of radar technologies, which are now today employed on satellites over the Arctic, for instance. And during the late 70s, the first civilian radar satellite CSAT was launched by NASA. And then the European Space Agency followed in the footsteps by launching its European Remote Sensing Satellite series, ERS, and then ENVISAT, the environmental satellite. And then subsequently, we've been developing the Copernicus framework together with the EU for a vast array of satellite capabilities for monitoring in general. Some of these have radars, which offer the possibility to image the Arctic day and night. So throughout the polar night, when there's no sunlight, we can illuminate the surface with a radar pulse, and that gives us the ability to image in all weather circumstances year round. That technology has opened up all kinds of monitoring possibilities as well as surveillance possibilities, and that draws parallels to the early CSAT images in the 70s during the Cold War, when one of the things that we noticed in the early radar images were locations where submarines were stationed in the Arctic. Of course, it was at a time where the Russians and the US would find a window in the ice to potentially launch missiles. And so there's been an intrinsic connection between space and what space offers in terms of providing this situational awareness in the Arctic. And that's the same situation we find ourselves in again today.
Can we learn, and that will be my last question for now, for this first episode of the Geopolitics of the Arctic, can we derive lessons from the Cold War or maybe the last year of how not to do things and maybe how to do things?
Well, as we came out of the Cold War, we recognized the importance of the connection to funding, of course, for space-based activities, but also for experimentation. The Cold War spawned many valuable and important chapters in polar science. And there's a good example from the Russian perspective. From the 30s onwards, throughout the Cold War and until the 90s, the Russians were putting out drifting ice stations in the Arctic. These were the only stations that were assembling knowledge on what was going on in the atmosphere and how the circulation patterns were changing both in the ice, the ocean, and the atmosphere. And these have been an incredible source of scientific knowledge. So despite the Cold War, there was valuable science going on up there. And of course, our collaborations were enhanced after the dissolution of the Soviet Union. We maintain connection with our Russian scientific colleagues, but on a political level, we're not entitled to work together. So we're in a fragile situation today where, of course, many of these collaborative relationships that have been developed since the early 1990s are at risk of dissolving. And that would be a real shame, of course, for collaboration for peaceful purposes in the Arctic.
So knowledge sharing would be the lessons. Let's continue with that. On the other hand, geopolitics have driven a lot of Arctic and polar research. Maybe we are in an era or in front of an era of a new golden period for Arctic research, although the incentives are not the most brightest. Today, Geopolitics of Arctic took center stage in our podcast. It's not only for fun that we're discussing it. We also estimate that the Arctic will take more and more center stage in ecological systems and also in geopolitics worldwide. We address the topics of the Arctic and science, or the Arctic and science, I have to say, of the role of ESA in this endeavor, and of course the influence of the war Russia in Ukraine, and how that influences both scientists and the science of ESA. We ended up in discussing the influence of the Cold War on the science of the Arctic, and it brings us to the real hardcore interest in the Arctic, and that's what we're going to discuss in the next episode. Today, we discuss these topics with a very interesting speaker, Mark Drinkwater. Of course, I was here with my good colleague and podcast partner, Rajeev Lachmipersad, and we hope that you were able to say goodbye to the uninformed you. Thank you very much for listening.